because you've studied Pythagoras before, over the last 6 years, and I'm pretty sure you would have done this for at least the last 2, and by the time you've seen this heading, you're groaning. But Pythagoras in 3 dimensions is really not that hard. It's just Pythagoras. It's just 2 steps of Pythagoras. The first thing you need to do is always draw a diagram. Okay? Even if there is one in the book, draw it yourself. Draw a diagram you can understand. Okay? The second step is to work out, okay, or identify the triangles you need. Okay, then all you got to do is leave things accurate until the end. And by accurate, we mean leave it as a square root of whatever it is. So if it's square root of 42, leave it like that. Just leave it as square root of 42 until you've finished all of your calculations. So first thing I'm going to do, I'm going to ask a question that's not in your book. All right, I've got a tissue box. Okay, here's my diagram. What is the largest pencil I can fit inside that box? All right, so that goes from this corner all the way up to this corner here. Okay, so all I need to do now is work out all the side lengths and stuff, and I'll be back with all the measurements we need. Okay, I'm back. These measurements are the measurements of the tissue boxes you can get from mathematics at school. All right, so we need to work out how I'm going to find the length of this red line. How am I going to be able to find that? The easiest thing to do is to make sure that you can see what's going on. Now, if I drew the hypotenuse on the bottom there, okay, that's going to give me a right-angled triangle sloping from this bottom corner up to the top corner, down and then back across the middle of the bottom. Right? Which means that I now have 2 right-angled triangles. I've got one on the base and I've got one sticking straight up from the base. And they're the 2 right-angled triangles I need to work out the length of that pencil that'll fit in this box. So the first triangle was the one, okay, and that was 22 centimetres by 11.5 centimetres. And I need to find that length there. So this is the one on the base of the tissue box. So if we do our c squared equals a squared plus b squared, so c squared equals, I didn't label them, a and b, 11.5 squared plus 22 squared, c squared equals okay, so there we have it. C equals square root of 616.25. Now I'm not going to work that out because remember the third step back over here on these was to leave things accurate until the end. So leave them like that until you're done. So now I've got another triangle which I had in green and red and black, and that was 5 centimetres. Okay, red is what we're trying to find, and the green one we just worked out. There it is there, square root of 616.25. Okay, you can't see that, sorry. So now we do the same thing again. This is my right angle. This is the hypotenuse, so we just go through Pythagoras again. C squared equals a squared plus b squared, c squared, and let's just do a and b, equals 5 squared plus square root of 616.25 squared. So c squared equals 25 plus 616.25, because that and that cancel each other out. So c squared equals, what is it, 600, and why isn't my brain working? 41.25. So c equals the square root of 641.25, and because this is my final calculation, I will actually work it out, and I get the answer 25.3229 centimetres long. Now I didn't set how many decimal places or anything like that, but that's the biggest pencil I could fit in that tissue box, from one corner on the bottom to the diagonally opposite corner on the top. So you can see Pythagoras in 3 dimensions is really not that different from Pythagoras in 2 dimensions.